Hi, I'm Channel Lakshita Lamaheva, holding the student ID 5018113. In this task, we focused on analyzing YouTube videos about a news topic published by BBC, Fox News, CNN and MSNBC news channels. A basic data cleaning had been performed on the collect data by the clean data function in collect.ipynb, so I did not add any additional data cleaning. Next, I will be explaining the data preparation process. First, we loaded two data frames from CSV files, videos.df for video information and comments.df for comment information. Next, we converted published at to date time. The published at column in the videos.df data frame represents the timestamp when a video was published is converted to a datetime object. Next, we create weekly, monthly, and yearly columns. New columns are created in videos.df to store the week, month, and year of publication based on published at timestamp. Next, we convert comment date to date time. Similar to step 2, the comment date column in comments.df is converted to a datetime object. Next, we create weekly, monthly, and yearly columns for comments. New columns are added to comments.df to store the week, month, and year of each comment based on the comment date timestamp. Next, we convert durations to seconds. The duration column in videos.df represents the duration of videos in the format of minutes, and seconds is converted to seconds. Next, we prepare 3 data frames for analysis. Videos data frame contains information about videos with additional columns for weekly, monthly, and yearly details. Comments data frame contains information about comments with additional columns for weekly, monthly, and yearly details. Videos comment inner is a merged data frame containing videos and comments using the video ID as the comment key in a join. Videos comments left is a merged data frame using video ID as the comment key left join. Now I'll be explaining the question E11, which compares the distribution of the number of views, likes, and comments for the videos. First, we define the column names for which we want to create the histograms using columns to plot. Columns to plot is a list containing the names of the columns for which histograms will be created. The columns include view count, like count, and comment count. Next, we create a figure with 3 subplots using 1x3 grid. This line creates a figure and an array of 3 subplots arranged in a single row and 3 columns. The total size of the figure is set to 18x5. Next, we loop over the columns and plot a histogram on each subplot. This loop iterates over the specified columns view count, like count, and comment count. By using this line of code, for each column, a histogram is created using Seaborn's histplot function. The KDE true parameter adds a kernel density estimate curve to the histogram. The plot is assigned to the current subplot AXSI. The next line of code sets the title of each subplot with the name of the current column in a capitalized format. And the next line of code sets the x-axis label of each subplot with the name of the current column in a capitalized format. With the next line of code, we can set the y-axis label of each subplot to frequency. Now we can customize and display the plot. By using PLT title layout, we can adjust the spacing between subplots to prevent overlap. And then we use PLT show to display the entire plot. As you can see, this code creates a figure with 3 histograms, each representing the distribution of view count, like count, and comment count. Now I'll be explaining the observations that I can see. Looking at the histograms, it's clear that the distribution of view count, like count, and comment count are not symmetrical. In a symmetric graph, you would see a balanced bell-shaped curve around the center. However, here the data shows a skewed distribution, meaning it's not evenly spread on both sides of the central point, which is at 0 on these graphs. Additionally, when we examine the histograms, we notice that the distribution for view count, like count, and comment count are positively skewed. This means that a small number of videos have higher engagement numbers while a majority of videos stand out with relatively low view counts, like counts, and comment counts. The bars on the right side of the histogram are shorter, indicating that only a few number of videos receive substantial engagement. Now I'll be explaining E1.2, that uses visualization to compare the total number of views, likes, and comments for the videos published by different news publishers. First, we calculate total views, likes, and comments by publisher. This line groups the video's data frame by the channel title column and calculates the sum of view counts, like counts, and comment counts for each channel. Next, we create subplots. This line creates a figure with 3 subplots arranged in a single row. The size of the figure is set to 18:5. Next, we plot total number of views, likes, and comments by publisher. These lines use Seaborn's barplot function to create barplots for the total number of views, likes, and comments respectively. Each subplot corresponds to one of these variables. Next, we customize and display the plot. These lines set titles, x-axis labels, and y-axis labels for each subplot to provide context and make the visualization more informative. The title layout and show. These lines ensure a tight layout of the subplots and display the entire visualization. The resulting plot shows 3 subplots, each illustrating the total number of views, likes, and comments by news publisher. Now I'll be talking about the observation. When we look at the bar graph, it's clear that CNN and BBC News tend to attract a larger audience as reflected in the higher number of views and likes compared to Fox News and MSNBC. The taller bars for BBC News and CNN indicate that these channels receive more views and likes overall. Another interesting observation is that while CNN and BBC News lead in terms of views and likes, CNN surpasses BBC News and other channels when it comes to the number of comments. The significantly taller bar for CNN indicates a higher level of audience participation through comments. On the other hand, there is a relatively less engagement through comments on BBC, Fox News, and MSNBC, all of which have similar lower comment bars. Now I'll be explaining E2.2. First, we create a new data frame containing only the comments data. This line extracts the relevant columns, video ID, and comment tags from the comments data frame and creates a new data frame called comments data. Next, we drop rows with NaN values in the comment text column. This line removes rows with missing values in the comment text column, ensuring that only valid comments are included in the analysis. Then we add a new column to store the length of each comment. Here, a new column comment length is created which contains the length of each comment. The AS type str ensures that the comments are treated as strings before applying the length function. Next, we group the comments data frame by video ID and calculate the mean comment length for each video. The comments data frame is grouped by video ID, and for each video, the mean comment length is calculated. The result is stored in a new data frame called mean comment length by this line of code. Next, we merge the video's data frame with the grouped comments data frame. The video's data frame and mean comment length data frame are merged based on the video ID column, creating a new data frame, merge data, that combines information about videos and their mean comment lengths. Next, we create subplots for each channel and plot scatter plots. Subplots are created for each channel in a 2x2 grid. Scatter plots are then generated for each channel where the x-axis represents the video duration and the y-axis represents the average comment length. And next lines of code represents a loop, and this loop iterates through each channel, extracts relevant data, and plots the scatter plot on the corresponding subplot. Each subplot has a title indicating the channel and labels for both axes. Next, we customize and display the subplots using PLT title layout and plt.show. Finally, the layout is adjusted for better presentation and the scatter plots are displayed by using these lines of codes. The resulting visualization allows us to observe how the average length of the comments varies with the duration of videos for different news publishers. Now I'll be explaining the observations. Looking at the scatter plots, it appears that there's a weaker correlation between the duration of the video and the average length of comments for all 4 news channels. We can make this inference because the data points are widely spread out and there is no discernible line or curve with closely spaced data points around it. This suggests that the average comment length across different channels may not be significantly influenced by the duration of the video. The next important observation is that the scatter plots for Fox News and MSNBC reveal the presence of outliers. Outliers are data points that significantly deviate from the overall pattern. In the case of MSNBC, there's an outlier with the video duration of 700 seconds and average comment length exceeding 400, and for Fox News, the outlier have a longer video duration over 1750 seconds and a relatively low average comment length ranging from 50 to 100. Now I'll be explaining the question E2.4. First, we remove the outliers using remove outliers function. This function takes a data frame and a column name as input, and it calculates the first quartile, third quartile, and interquartile range of the specified column. It then defines lower and upper fences to identify outliers. Finally, it returns a new data frame without the outliers based on the specified column. The remove outliers function is then applied to the comment count and like count columns in the video comments in a data frame. Next, we create a figure with two subplots with a specified size. After that, we plot the distribution of likes and comments per news publisher using box plots. Two box plots are created using Seaborn's box plot function. One box plot represents the distribution of the number of comments across different news publishers. The other box plot represents the distribution of the number of likes across different news publishers. Now we customize the plots by giving them titles, x-axis label and y-axis labels. Then we display the plots with a tight layout using these two lines of code. And now as you can see, there are two sets of subplots that display the distribution of number of comments across different news publishers and distribution of number of likes across different news publishers. Now I'll be explaining the observations for these box plots. Looking at these box plots, it's interesting to note that the minimum values for both comments and like across Fox, BBC, CNN and MSNBC are almost identical. This suggests a consistent baseline engagement level among these news channels. The reason behind this could be the nature of their content, focusing on current events, ensuring a steady and similar level of interest from their audience. The second observation is that both BBC News and CNN show remarkably similar maximum values for both likes and comments. This implies at the upper end of the engagement spectrum, the peaks for likes and comments are almost identical between CNN and BBC. Now I'll be talking about the challenges and obstacles I ran into. One challenge I faced was dealing with the NaN values in the comment text column. Because of these values, I kept getting errors in the code I wrote for E2.2.2, and I overcame this challenge by dropping any rows with NaN values using the drop-nav function. Another challenge I faced were understanding the histograms and box plots I created to make observation and gain insights. I overcame this challenge by watching many educational videos on histograms and box plots. Now I have come to the end of this video. Thank you.